Welcome to Keys to the Future. I'm your host, Gabby Coe. I've enjoyed a successful engineering career and want to inspire you to remain focused on your STEM education and career. Join me as I chat with amazing guests who are shaping the future and sharing their journeys to inspire yours. Ready to unlock your potential? Let's dive in.
Joining us today are three young innovators making waves in the world of STEM as they lead Team Inspiration, not only building robots, but also breaking down barriers and inspiring their community.
Our panelists are Mabel Szeto. She's a student at the University of California, San Diego, majoring in cognitive science, specializing in machine learning and neurocomputation with a minor in theater. She's expected to graduate this spring. Mabel is an accomplished engineering student with much internship experience automating flight data processing and designing visualization tools. Mabel is an active innovator in robotics and immersive technology. As a key member of Team Inspiration, she helped lead the team to a fourth place global ranking in the robotics competition, where they developed autonomous multi-domain vehicles. Colin Szeto is a student at the University of California, San Diego, majoring in mechanical engineering, and is expected to graduate this spring. Colin has held many internships where he excels in software development, systems integration, and team leadership. As the team lead for Team's Inspiration in the RobotX competition, Colin directed the design and operation of autonomous boat and drone systems, with the team achieving a fourth place ranking globally and earning the Collaborative Systems Engineering Award in 2024. Eesh Vij is a sophomore at the University of California, Irvine, majoring in computer science with a minor in entrepreneurship. He has 9 years of competitive robotics experience, and he is skilled in programming and autonomous systems and has led the team to success, including a RoboSub World Competition in 2020. As a captain and systems lead, he led the team in achieving top rankings in RobotX and RoboSub competitions.
Wow, you are all accomplished engineers so early in your careers. Very, very impressive. Welcome and thank you for sharing your perspective with the Keys to the Future community.
Thank you.
Thank you for having us on.
Very excited to be here.
Excellent. Well, let's dive in. So you are, like we've been saying, you are all part of the Team Inspiration, a robotics team based in San Diego, California. What inspired the team's name, and how does it reflect your approach to robotics?
Team Inspiration was not a unanimous decision. We actually went through multiple stages of voting. However, it did come up in every stage and it stuck after that. We selected the name as we based it off the Inspire Award, the highest level of recognition within the robotics competition our team was founded in, First Tech Challenge. Since then, we've grown into the name by pursuing local and global outreach efforts, as well as what technical development and accomplishments we're able to achieve with a small, dedicated, community-based robotics team.
That is excellent. Wow, it appears that you have all been part of this team for some time now, and I'm curious about how your team has evolved over the years, both in terms of skills and the projects that you have worked on.
Yeah, so as a team, we've definitely grown a lot in experience and technical knowledge. And with that growing experience, we branched out into more and more challenging competitions. Many of our teammates actually started with autonomous Lego robots. As Colin mentioned, Team Inspiration itself started with the aluminum RC autonomous 18-inch cubed robots from First Tech Challenge, but we've since moved on to underwater autonomous vehicles in 2019, unmanned surface vessel competition in cooperation with a autonomous drone, as well as surface vessels by itself. We still keep the middle and high school team that does the aluminum RC robots. This way that we can build a pipeline to help students develop their skills from middle and high school programming robots that are basically a kit of parts to where we are now with the boat and the drone working together, where we get to make all of our own design decisions, creating our own components, machining them, as well as also doing trade studies and buying commercial like sensors and stuff off the shelf.
Wow, that is awesome. You mentioned the whole engineering, and we're going to get to that. I won't jump into that, but you mentioned really a part of the engineering process that you go through, and also involving teams early on at the middle school level, you mentioned, right? Into high school and then university as well. Is that true?
We do have a very wide range of team members in terms of age and skill level. We try to foster as much learning and curiosity as possible. We encourage every team member to learn a little bit of everything before they kind of focus in on whatever they want to learn more on. So we try to get everyone to do at least a little bit of hands-on building, programming, and everyone also has to do outreach and sharing.
That's great because you share the load, if you will. Then you also help others learn the different parts of your operation, if you will. You are operating a team. And so that is really awesome. And at the beginning, you three were primarily in learning mode, most likely. So, and you gained the skills, you evolved into the leaders, and then you're evolved also into the mentors that you are to others in within the teams. You mentioned middle school and high school levels, and now you yourself at the college level. So, can you take me through the process of building a robot from scratch and what role each team member plays?
Yeah, absolutely. So, from the start, even back when we were in our early Lego days, we had a huge focus on the systems engineering process, which was kind of handed down to us from our mentors. The process can usually is defined as like a V, where you start at the top with your goals, and these are very high level oriented goals. Where Mabel mentioned our 18-inch cubed robot, some of those goals would be taking an object and shooting it through a target or something of the sort. So, it'd be a very high level goal. After that, you get into your low level requirements where you want to define, let's say, how fast your object has to shoot, with what precision, if you want, how many degrees of freedom, as in, like, can you direct where you're shooting? And then once you have those levels defined in your robot or whatever your project you're trying to design, you can actually get into that design and testing phase where you kind of iteratively go back and forth, try different things. And essentially, your goal right now is to meet those requirements. This is at the very bottom of that engineering B I was talking about. And you kind of sit here for a while. This is where most of our season and competitive time goes into, where we're trying to develop our robot. After that, we head into our verification and validation stages, where we're trying to verify that, hey, did we actually hit our requirements? And then also, the validation part comes from, hey, do our requirements and what we hit actually satisfy our goal of, back in the very beginning, actually shooting the object through the target. Given that process, we're actually able to split that up between our team members into various different roles, typically split between the software side of the process, the electrical, and the mechanical. Both the mechanical and software are typically the polar opposite ends when it comes to robotics, where one is very physically oriented and one's completely virtual and digital. The electrical factor ties it together and is very important in any autonomous or robotic system because it helps characterize the model dynamics, how we can actually actuate the robot. And in putting these all together, we typically need some integration rules as well, who are keeping this big picture in mind and able to combine this mechanical, software, and electrical processes into one large system engineering process.
So, as a systems engineer, if you're speaking my language, you mentioned the systems engineering V. You start out with your high level goals, then you decompose into high level requirements, systems, subsystem requirements. Then you design and test or develop into your verification, your V and V verification and validation. But you have to also include the different disciplines. You mentioned hardware, software, mechanical, electrical. So you're running a little engineering company, if you will, at your level. So that is amazing. So I am curious also, does everything go according to plan? Or actually, let me go back a little bit because we talked about the process itself, but what role does each team member play?
So we typically, those requirements are boiled down into specific tasks that we'll give to certain team members. So we'll have a mechanical subteam, the electrical, and software. And within those sub teams, the leads are working with some of the high level, like technical director roles, where they're handling the integration. And then within the leads, they kind of direct those requirements to each individual person. So like you said, it actually does become very much like a little company in a sense, an industry where you kind of follow that same process. And I think the reason we follow that process is because we've gotten so much mentorship from industry ourselves. And I think that's also helped us grow a lot as a team because we're following best practices.
That's excellent. That's just really amazing. So I'm also curious. Does everything go according to plan? How do you handle the technical and mechanical and software integration challenges that come with a robotics project and with any project that involves that level of different disciplines and different components and subsystems?
Yeah, it's always a challenge. Obviously, the goal by following this process is to avoid these integration challenges in the first place. If we plan it out well enough from the get go, we're able to not hit them, but eventually we do. Everyone does at some point. And when we usually do, we try to go through the most malleable systems to some of the more rigid ones. So, in that sense, like, hey, in this integration, we're having some issue. Can we make a software adjustment to accommodate it? And then we move on to the more electrical, like, hey, can we redefine, maybe use a higher spec motor or a smaller sensor, essentially going down that. And eventually we reach the mechanical side where, let's say we had to manufacture a component. If we were within our deadline and we have the time, then sure, we'll remanufacture it, reassemble, and adjust that way. But worst case scenario, let's say we're on that tight deadline, none of our components can be easily adjusted to hit that deadline, then we typically have to come to a compromise and we're like, hey, we started the season with these goals. What was our minimal viable product? And we really try to just, okay, we'll reduce our scope a little bit and only focus on what we need in order to succeed, even if it's at a slightly worse performance.
I am so delighted to hear you speak in those terms because in the industry, we are always working iteratively and learning from what we find, like the information. So in some cases, we need to gather more information to be able to go forward and affect the design or maybe make some tweaks to the design, as you mentioned. So I am delighted to hear you say that at this early stage in your careers, and you're also teaching, mentoring the others that are coming up with you to learn these terms as they come up in the different levels, middle school, high school, and then getting into college, and then eventually industry. So those terms and those methodologies are no longer, or hopefully will no longer be foreign to them. I am so delighted to hear you say that you're implementing these best practices from industry is something that we in industry strive to do every day. So I am super stoked. You are all very accomplished in your early careers. How does the team prepare for competitions and how do you handle the pressure of competing with other skilled teams, highly skilled teams as well?
As always, we want to start as early as possible. As soon as one season ends, typically we want to start immediately, but also everyone kind of wants a break because we've been through a high stress environment on the weeks leading up to competition. But the goal always is, hey, we start as early as possible and we really try to focus on that initial research and that test driven development phase where we're kind of like, hey, this is what we kind of gathered last year. This stuff worked, this didn't work. And then we try to iteratively kind of see like, hey, let's tweak it a little bit because we have that little buffer in the beginning. As we get closer and closer to competition, we want to make sure that all of our individual tasks that I was mentioning earlier, we try to master from a fundamental level so that we're able to kind of build on them as the season grows and understand that, okay, we had this system before. How can we tweak it as we get closer to our actual competition requirements? And what do we want to do? And you mentioned the pressure of competing. And yes, absolutely. There is that pressure of that. We want to succeed and we kind of want to show off that, hey, we are a competitive team and we're able to essentially compete and win this competition. But at the same time, there's also that excitement that I like to think overwhelms that pressure of, hey, we're going to this competition, we're meeting teams from all around the world, and there's so much to learn from them. Because although we're in these robotics competitions, ultimately these competitions are not work contracts or things like that. These are for us to kind of grow ourselves and grow the community. And I think that's a great spirit that we foster in these competitions because we want to succeed, but we also want to learn and improve.
And I'm also curious, you mentioned you competed in the world stage. So what are some of the interesting places that you guys have gone to compete?
We started our kind of this competition journey of international competitions. We're all based in San Diego. So luckily the first one we went to was actually right in our hometown in San Diego. It's called the International RoboSub Competition. Great opportunity for us because as we came to realize with Robot X, which was actually in Australia in 2022, shipping costs are a huge problem and a huge budget. So with the competition, our first year in San Diego, we were able to actually really focus on the competition and just drive there. We were able to allocate budget more towards our research and development phase than it would have taken for our logistics. But yeah, like you mentioned, the places we've gone, starting in San Diego, eventually branching out to Australia for Robot X, coming back to San Diego, and then Irvine in California. I personally went to Maryland for the SUAS competition. We've gone to Florida for both the RoboBoat and Robot X competition. Luckily, so far, a majority have been within the US, which helps us a lot as far as shipping goes. In fact, this year for Florida, Coach Alex, our mentor, he graciously offered to drive from California to Florida with our competition vehicles so we could also save on logistics there. But after a conversation with some of the directors of the competitions we go to, they're thinking of branching out maybe back to Singapore where they hosted before we joined, or potentially Hawaii as well. So they're always looking for new venues, new places, new sponsors, and we kind of just go with the flow and we're just happy to compete.
Although we haven't physically moved for competition as much as maybe one could perceive, we've actually stood up and organized a couple international competitions as well. Way back when, we traveled to West Africa, Benin, where we held their country's first robotics competition. And more recently, in Paraguay, South America, one of our partner robotics teams was able to host their officially recognized First Tech Challenge robotics competition there. So not only do we spread our presence around the world globally through competition, but also through international outreach events as well.
That is amazing. Wow. I sit here and I'm just listening and I'm super stoked to be talking to such an accomplished group of young people that are affecting change at the global level. That's amazing. So, for those who are listening and thinking they are interested in robotics and joining this movement of, at the global level, what advice would you give the students that are aspiring to be engineers or getting involved in robotics?
I would recommend selecting a project that one themselves is committed to see all the way through. And by scoping the project and making this commitment to oneself, they'll run into technical challenges that they could not even foresee. And one of the most important aspects of engineering is learning how to learn. Using the resources and mentorship around you, you'll be able to seek out answers to your questions that you didn't know you'd have. And through taking on new projects, you'll gain new skills and create new connection points. Additionally, there's a lot of monthly build boxes, if you will, such as KiwiCo and Crunch Labs, if you want a more individualistic approach to take after your own learning. However, there are many local and global robotics competitions as well, such as FTC or VEX Robotics Challenge are some quick introductory robotics teams you could reach out to as well.
Excellent. So you mentioned start small, that you're not overwhelmed at the beginning because there's a lot to do and learn. But starting small, and then also you mentioned something that I think it's very key for people to do is if you get stuck, reach out to others that are in that space and see how they did it and get some help. So I really love that input. I'm also curious though, how does your team inspire others to pursue the STEM and robotics, particularly in your community? And you have already kind of touched upon that, but can you go at a deeper level, specifics?
As a team, we've always emphasized the importance of sharing knowledge and learning through teaching because you never really fully understand the grasp of your subject until some little kid is asking you, how does this work and why you did that? Making sure that you can adequately explain your thought process and your design process is always a fun challenge. So we've done a lot of recurring outreaches. So summer robotics camps with University of San Diego's STEAM Academy. We also do robotics camps with Urban Life Ministries and at Manos Martial Arts. We also exhibit at local STEM fairs, STEM expos, as well as professional conferences. One of the reasons why we go to professional conferences is to encourage students to explore robotics, as well as getting professionals to be more involved, to be mentors for local robotics teams or global robotics teams. We've worked with a bunch of different robotics teams at many levels and try to facilitate like monthly open houses and sharing our resources, because we've built up a lot of stock in our garage through competing all these years, and we try to encourage team members, if they can't join our team, also join other teams. Since we've been involved in the community for so long, we always want everyone to be able to do things at the level that they're currently able to.
And so you mentioned you've been involved in the community from a little while. So just how long has that been? Because it sounds like you have things in your garage and things that you've accumulated over some time. So I'm just curious, how long has the team been around?
Conceived in 2016.
Yes, it's been a while.
That's commendable. And I'm also curious, how many people in your team, or do you have different teams of how many people each?
Yeah, we do have different teams. So for the different levels, robotics, we have 14 members, which is a fairly flexible number since we also have capstone students that join our team for a semester, a quarter, to assist with specific parts of our project. For RoboSub, last year we had 7 team members, and our current FTC team is at 5. Yeah.
Wow.
And then RoboBoat is also going on with a varying number of people. I think it's currently around 6.
Okay. And how many levels do you have? Are the teams made up of team members that are at different skill sets, different skill level?
Yeah, so the RoboSub, RoboBoat, and RobotX teams all kind of share some team members, because a lot of the applications are fairly similar. And then our FTC team is mainly just middle and high school students, and the RoboSub, RobotX, and RoboBoat team members mentor those students.
Okay. And how do you decide who goes to what team? Or is that based on the team members' desire and skill level?
Yeah, it's mainly interest, because for us, we always encourage team members, as long as you make the time commitment and you show up, work on the project, then you can get to this level and you can compete at this international stage. So it's mostly up to the personal desire of the team member, as well as when the competition is. So RobotX happens every 2 years, so we don't work on it as much in the year right after the competition. We focus more on RoboSub and RoboBoat, which happen every year, to kind of build up that skill set so that we can be prepared for the next competition.
So do you have like a CEO of the group?
So our Coach Alex and Coach Teresa, Mabel and Ara's parents, they have kind of the leadership aspect and the big picture execution of where the team is heading towards. And then kind of, if you will, the technical leads would be within the students themselves. So for example, Eesh is spearheading the electrical and software development. I would help spearhead the mechanical and fabrication efforts, and then Mabel would be spearheading our business and optics department, if you will. So the team is made up, and all the leadership it's a team sport, if you will. All of us can bounce off ideas of one another and help strengthen the team's mission, as well as our efforts within competition and in outreach as well.
I love it. Yes, I agree. Engineering is a team sport. You need everyone and everyone's input. So, as you mentioned earlier, you evolved within the team and you yourselves have been mentors to others. But I'm also curious, how important is mentorship in your journey and your team's journey? And do you have any mentors who have had significant impact to your success?
Yeah, mentorship's almost like a superpower. You can take your lifetime of experience and distill it down into a couple sentences to impart some advice as well as technical details. And then right when your student receives it, they can say it back to you with their perspective, and then it kind of shifts because you've never heard it in that kind of light. Some mentors that helped us out significantly, I'd like to shout out Dr. Jack Silberman. He actually got the initial interest in robotics within my family, and that has spun into Team Inspiration till today. He's helped out with a lot of high performance teams and really imparts that kind of dedication and commitment it takes to team members, and tries to advance or keep advancing us with the pace of technology, always encouraging us to implement new technology. And I'd like to shout out some of the mechanical mentors that helped me grow mechanically, like Phil Yao and Michael Arnstein. They put in countless hours our first year trying to teach us about threads, correct fastening methods, and unique build styles as well.
If you could build a robot for any personal use, what would it be and why?
I would love a robot that can identify textile composition. So, like, what's it made out of? What's the weave? How was it constructed? And also washing instructions in a non-destructive way, because I have a minor in theater and I focus mostly on costume design. So we have a costume shop on campus, and a lot of the fabrics, especially things that were bought multiple years ago for a different show, we don't have like a tag on it, so we don't know what it's made out of. We know what color it is because we can see it, and we can kind of figure out how it was constructed based off of how it feels. But the main way we figure out what it is we do a burn test. So you just set a little piece on fire and you look at it. How did it react? Did it melt? Did it turn to ash? How does it smell? And obviously that's good, so you know what it is, but it's also destructive. So if you have like an old garment that you don't know what it's made out of, you don't want to burn a piece off just to figure out what is it. So I would have a robot for that.
Interesting, very interesting. How about you, Colin?
Inventory management is always a struggle. It's a constant iterative process, and I think having a robot to help streamline that process, intaking inventory, storing it away, and then being able to call it back up for major use would be something I'd be very interested in developing and implementing.
Especially because you mentioned you have a lot of things in your garage, right? That's
Yes.
great.
There's a lot of lean principles we've yet to implement, but it's always an iterative and learning process.
That's great. That's great. How about you, Eesh?
For me, maybe it's slightly different, but like still falling within autonomous vehicles for me, because that's what I love doing. I skateboard to campus from my apartment every day, and I would love if I could make an autonomous skateboard. Right now, it's an electric skateboard, and like it's easy, but you can make it so much easier. Imagine you just stand on it, and it'll just take you where you want to go. So I think that would be a very cool robot to see happen. But yeah, that would be it for me.
Great. So if people wanted to find you, do you have a website that you can share? Where can people find you?
Teaminspiration.global, and that will give you a rundown of our outreach as well as competitive robotics experience, and you can actually meet each individual team member, and there's contact information for you to follow up with them on the website.
Excellent. Your team lives up to its name. Thank you so much for joining us today and sharing your inspiring journey with the Keys to the Future community.
Thank you.
Thank you so much.
Thank you.
And that's a wrap for today's episode. Don't forget to follow Keys to the Future on Apple Podcasts, Spotify, or wherever you listen to your podcast for more inspiring stories and industry insights. Until then, keep innovating and stay curious.